right then. Now, let's have a look at this problem. So say you are given that let matrix A to be equals to 1, 2, 1, 0, 1, 0, 1, 3, 2. Say you are given matrix A to be this matrix. And then the question says to us, find a matrix B such that AB is equals to A squared plus 2A, okay? So we are most definitely provided with this equation. Now, when we want the solution based on this solely information, this is what we are going to do. Let me change my color pen. So now we are given this equation, right? This is our solution. So we have AB matrix A multiplied by matrix B is equals to matrix A squared plus 2 matrix A. Okay. So now this is what we are going to do. We are going to introduce, because remember, we are looking for matrix B, not AB. We are looking for matrix B. So I'm going to have to make B subject of the formula, whereby I have to eliminate matrix A. But here in matrices, how do we eliminate matrix A? We're going to introduce the inverse. So that means on this side of the equation, I'm going to multiply the whole thing by matrix A, by inverse of A. Okay, I'm going to multiply the whole thing by the inverse of A. But for a fact that this is an equation, remember what I do on the left-hand side of the equation, I'm supposed to do it on the right-hand side of the equation. So that means even this one, I'm going to multiply it by the inverse of A. But remember, what is A squared? It's A multiplied by A. Plus, same applies to here. I have 2 multiplied by inverse A multiplied by A. Now, what is inverse A multiplied by A? So remember, when you multiply a matrix by its inverse, you get what you call the identity. So that means here we're going to have the identity matrix multiplied by B, which is equals to, same applies here, we're going to get identity matrix multiplied by A plus 2, same applies here, we're going to get the identity matrix. But remember, we are not looking for identity matrix B, but we are looking for matrix B. So that means, according to the laws, we know that identity multiplied by matrix, it is that matrix. So that means identity multiplied by matrix B is going to yield to matrix B, which is equals to identity multiplied by A is going to yield to matrix A plus 2 multiplied by identity. So that means this, it is a formula that we are going to use to determine the matrix B. But now, how are we going to do that? So now, as I continue with this equation, so I'm going to say matrix B now is equals to, now, what is matrix of A? So matrix of A in this case, it is provided to be 1, 2, 1, 0, 1, 0, 1, 3, and 2. This is matrix A. Therefore, plus 2 multiplied by, now what is the identity matrix? Now, this is what is happening. It depends on what matrix are you adding on to. So your identity matrix in this case, it's supposed to be 3 by 3 identity matrix, because you adding your identity matrix to 3 by 3 matrix, which is matrix A. So that means in this case, for this addition to be defined, we need to take care of that, to know that when you add the two matrices, they're supposed to have same number of elementary entries. So that means that our identity matrix is going to be 1, 0, 0. Remember, 0, 1, 0, 0, 0, 1. So remember, when you talk about the identity matrix, your diagonals supposed to be all leading ones, supposed to be non-zero, which is 1, 1, 1, 1. And therefore, now I'm going to say matrix A, which is given by 1, 2, 1, 0, 1, 0, 1, 3, 2. I multiply by this scalar into this matrix. It's going to be 2, 0, 0, 0, 2, 0, 0, 0, and 2. Voila. Therefore, now these matrices are defined to be added because they have same elementary entries. So you're going to have first entry to first entry. It's going to be how much? It's going to be 3. Second entry to second entry, it's 2. 2 plus 0, it's 2. 1 plus 0, it's 1. Therefore, 0 plus 0, it's most definitely 0. 1 plus 2, it's 2. 0 plus 0 is most definitely 0. 1 plus 0, it's 1. And therefore, 3 plus 0 is most definitely 3. And then 2 plus 2 is most definitely 4. Therefore, this will be the matrix of B.